Unit 2, Day 1, Honors Geometry Notes. Let's get right after it. All right, this first topic asks us to identify pairs of angles that have certain relationship names. Okay, here we have corresponding angles, alternate exterior angles, alternate interior angles. So 3 vocabulary terms. Corresponding angles, I thought I would just jazz it up a little bit. So I made, instead of just numbers in here for these angles, I put some pictures of some folks that were famous. Either they're famous recently or they're famous, for their lives from, before, shall we say. Okay, so corresponding angles. What I would tell you this, I would tell you that each of these intersections is kind of like a separate little game all by itself. So I'll make one gray and one red. So like for the gray intersection, there are 4 angles. For the red intersection, there are 4 angles. So things that are in the same relative position correspond to each other. And in this case, angles that are in the same relative position correspond to one another. And what I mean by relative position is this. Let's say that this is I know it's only a 2x2, but let's say that's like a tic-tac-toe board. And tic-tac-toe board, you would say, I'm going to put an X in the upper left or the lower right or the middle left or right or something like that. So like, for example, you got Marilyn Monroe here. That's in the upper left position of the gray intersection. You have Jennifer Aniston, AKA Rachel from Friends, in the upper right. The king of rock and roll, Elvis Presley, in the lower right position. You have Dwayne Johnson, AKA The Rock. If you smell what he's cooking, he's in the lower left-hand position. We've got Abraham Lincoln in the red intersection, upper right. We have Shaquille O'Neal's head in the upper left of the red intersection. We got Mike Tyson, actually dressed nicely, face tattoo and all, in the lower right position. And good old Albert Einstein in the lower left position for the red intersection. So corresponding angles, if you could take each intersection pair, in this case, the green group and the red group, and you say, I want one angle from each relative position. So let's say, for example, we want to go lower right position. The lower right position in the gray intersection area is Elvis Presley. The lower right position in the red intersection area is Mike Tyson. So we would say that angle Elvis and angle Mike Tyson are in corresponding positions. So they are corresponding angles. So for our answer, let's do a different one. Let's say, let's go with The Rock, or Dwayne Johnson. He's in the lower left position. Okay? In the red intersection area, that group, lower left position, if you remember, that's good old Albert Einstein. So we got Dwayne Johnson, also known as The Rock, and Albert Einstein. Right? They are all, they are corresponding angles. Their positions correspond to one another. Therefore, they are a corresponding angle pair. All right, because now we are going to look at exterior or interior, but we're going to look at exterior first. Right, so exterior. Now we have lines L and M that are crossed by transversal N. Okay? So the parallel lines are what we look at when we're determining which angles are exterior and which ones are interior. Okay? Interior means inside of them. So these angles are inside of the 2 parallel lines. Abraham Lincoln, Elvis Presley, The Rock, and Shaq all four of those angles are interior angles. Meanwhile, exterior angles would include everyone that's on the outside of the two parallel lines. So exterior angles would include Marilyn Monroe, Jennifer Aniston, Mike Tyson, and Albert Einstein. Those are exterior angles. All right. Now, alternate means you're going to alternate sides of the transversal. So here's the transversal. Now, some of these angles are either above or to the left, whatever you want to call it, and then others are going to be below or to the right in this case. So this group alternates with this group. So we need two angles that are exterior that alternate. Now, the only other thing we have to say is that in Unit 1, we talked about two lines, intersections, we did vertical angles, we did linear pairs. That's a bunch of Unit 1 stuff. So we can't use linear pairs and we can't use vertical angles in Unit 2. So we will need to take one of these angles and one of these angles and say they're alternate exterior. All right, so exterior angles, as we said, we could pick any of these four. Okay, let's start by picking one that we haven't picked here yet. Let's pick Marilyn Monroe. Okay. Exterior. So alternate exterior. Is it Jennifer Aniston? They're a linear pair. That's not alternate exterior. Is it Albert Einstein? Well, if you look at the transversal, he and Marilyn are on the same side. They're same side exterior, also known as consecutive exterior. So no, unfortunately, Albert is not alternate exterior. That leaves us with Iron Mike. Iron Mike is on the other side of the transversal N, and he is exterior. So he was both alternate to Marilyn Monroe and he's exterior. So we could say Marilyn Monroe and Mike Tyson are alternate exterior angles. We could have also said Jennifer Aniston and Albert Einstein. Okay, they are also alternate of each other and they're both exterior, so they're also alternate exterior angles. Could have two answers on that one. So finally, we have alternate interior angles. So remember that the interior angles are the angles that are between the transversals. So if we look at those, these guys again, pick any one of them. Let's pick Abraham Lincoln. Okay. Who is alternate exterior, or excuse me, alternate interior with Abraham Lincoln? All right, is it Shaquille O'Neal? They're a linear pair. Okay, linear pairs are on the same intersection, and we are not going to have any relationships that are on the same intersection, right? So they are not alternate interior. Elvis Presley, unfortunately, Elvis is on the same side of the transversal as Honest Abe. Therefore, they are not alternate interior angles. That leaves us with Dwayne Johnson, The Rock. He and Honest Abe are on different sides or alternating sides of this transversal, and they're both interior. So they alternate and they're interior. So we would say for one example of alternate interior angles, we would say Abraham Lincoln and Dwayne Johnson, AKA The Rock, right? Now, we could have also said Elvis and Shaq are alternate interior angles as well. So again, there's two possible answers for the alternate interior angle pair. Okay, let's scoot down this page. All right, so here they are giving us that the lines are parallel, cut by a transversal. So if they're parallel, we have some really nice relationships that we can use to solve for any angles. So if you know that two lines are parallel cut by a transversal, and I give you one of the 8 angles that are formed, see the 8 angles? If I give you one of them, you can get the other 7, and you're not even going to think it's difficult. Okay, I guarantee it. Watch this. So measure of angle 8 right here is 141 degrees. All right, check this out. Let's get all the angles. All right, let's just get them all. Okay, so step 1 for me is where you take the same intersection, find all the angles at the same intersection. So right there, this intersection. Well, from unit 1, we can easily do this. If angle 8 is 141, its vertical angle, angle 6, is also 141 degrees. Then we can also say, I know angle 7, because angle 7 forms a linear pair with either 8 or 6, take your pick. So if you say linear pair with 141, we simply take 180, we subtract 141, we get 39 degrees. Angle 7 is 39 degrees. Vertical angles, angle 5 is also 39 degrees. Okay, so we've got all 4 of those angles at that first intersection. And now step 2, to finding every single angle, corresponding angles are congruent. So we literally just have to copy it. Where is angle 8? I would say it's on the left side of that intersection, bottom left maybe. So which of these angles, 1, 2, 3, or 4, is on the bottom left? Well, obviously it's 4. 8 and 4, same relative position, different intersections. Okay, they are corresponding angles. And if you have 2 parallel lines cut by a transversal, then corresponding angles are congruent. So this is a 141 degree angle. Also notice that 8 is obtuse, 4 is obtuse, right? Angle 7, it's the lower right angle in this first intersection out of this other intersection with angles 1, 2, 3, and 4, which is the lower right angle. If you said angle 3, I would agree with you. 39 degrees for angle 3. Right? Notice angle 7 was acute, angle 3 is acute. Well, once you have that, I mean, angle 6 corresponds to angle 2, 141 degrees, and angle 5 corresponds to angle 1, 39 degrees. Right? So you just have 2 identical sets of 4 angles that are all in the corresponding positions. Okay? And that happens when you have 2 parallel lines cut by a transversal. So now let's just look at what they're asking us. What's angle 1? Angle 1 was 39 degrees. Angle 3 was also 39 degrees. Right? So just to make sure that we are prepared for future topics, let's look at the relationship here between 8 and 3. Angle 8, which they gave to us, and angle 3, okay, they're same side interior, the consecutive interior. One of them is obtuse and one of them is acute, right? They are supplementary. Just a quick heads up. If you have 2 parallel lines crossed by a transversal, consecutive interior angles are going to add up to 180 degrees. We already said that corresponding angles are going to be congruent. Alternate interior angles, angle 8 and angle 2, we saw that they were both 141. Okay? Alternate interior angles, alternate exterior angles, they're congruent. Okay? alternate interior, alternate exterior, and corresponding, all congruent. And then consecutive interior, consecutive exterior, those will be supplementary, right? So you can rewind and fast forward or whatever and go back and replay me saying that as many times as you want. You know, that will help you when we get to the proof of parallel lines at the end of this lesson real quickly. All right, so now we've got a pair of parallel lines. We're going to solve equations, not just say, oh, here's a number. Okay, so they've given us this angle is 5y minus 12. They've given us this angle is x, and they've given us this angle is 77. Okay, so we need to find two angles that have a relationship with one another, and you can't have two variables in an equation. Can't use two different variables in one equation. Okay, because you know that these two angles are vertical angles, the x and the 5y minus 12, you know that. However, you can't say 5y minus 12 equals x, because now you've got a y and an x. We need to solve and get numbers only, okay? So we need this 77. We need the 77-degree angle in our equation. Well, the 77-degree angle, we could think of this a couple ways. If you remember everything I just said about consecutive interior angles, then you would know that the 77-degree angle and the x are consecutive interior angles, and they would add up to 180. If you don't remember that yet, then I would ask you to remember the big thing that we talked about just a minute ago, and that is all the corresponding angles are congruent. So if this is 77, that's in the lower left of this intersection. That tells me that its corresponding angle is also 77 degrees. That makes this much easier. That makes this a unit 1 question, because now if you look at that x and that 77, you can see that those two angles form a linear pair. Okay? They form a line. So that means that x and 77, because they form a linear pair, they're supplementary. They add up to 180 degrees. Well, that makes it pretty simple for us. We're going to subtract 77 from both sides of the equation, and you get x is 103. And if I know x is 103, now you can relate it to this 5y minus 12 angle, because 5y minus 12 is vertical with x, or vertical with 103. Vertical angles, you learned in the last unit, are congruent. Right? So 5y minus 12 has got to equal 103. Right? Let's add 12. 115. 5y equals it. Divide by 5. So we get y is equal to 23. Find the values of x and y is what they asked. We answered their question. Great. That's not too bad, I hope. All right, so let's look at this next question below it. This time they just gave us an extra set of parallel lines. So it says H is parallel to L and J is parallel to K. So these guys are parallel and these guys are parallel. So corresponding angles are congruent. Alternate interior, alternate exterior angles are congruent. Corresponding angles are supplementary. Okay, for any two parallel lines with one transversal. So let's look at what they gave us. They gave us this 65. Okay, now the x that they've given us is way over here. The y that they've given us isn't too far away. Okay, so what I would like to do is I would like to try to find the y first. Okay, you could do the x first, it doesn't really matter. I'm going to find the y first. So I'm going to find a corresponding angle to this 65. Well, if I'm looking at this transversal and parallel lines J and K, then that 63-degree angle, just making sure it was 63, that 65-degree angle, my eyesight's going, that 65-degree angle is in the lower right position, okay, of this intersection. So if we're looking at this intersection, 65 degrees, I'll write a little bigger so I can actually see it, is right here. Okay, corresponding to that in the lower right is this lower right. So that's 65 degrees. Okay, now that I know that's 65 and that this is y, okay, these are a linear pair. So I know that y plus 65 equals 180. Awesome. Okay, I'm going to subtract 65, subtract 65. Y is equal to 115. Okay. And then finally, now that I've got this position as a 65 already, I'm pretty close to the x. Tell me about this angle and this angle. Now, we just need to look at which parallel lines we're going to be focusing on. So let's get rid of those. I'll rewrite it in a second here. So this is 65, we said. Okay, so if we're looking at this angle and this angle, that means we need the transversal that forms both of them. We need this transversal, cha-ching. Okay, that transversal is crossed by these two lines, these two parallel lines. Okay, so what is the relationship name for this angle and this angle? They're both on the lower right. So that tells me I've got me corresponding angles. It means that this angle right here, 4x minus 19, or 4z minus 19, 4z minus 19 is 65 degrees. So I'm going to go 4z minus 19 is equal to 65. Okay, let's add 19. 4z equals 84. Z is 21. Blackjack. Okay, so we've got y, we got z. We used corresponding angles right there. All right, this next little topic here asks us to establish facts about angles when parallel lines are crossed by transversals. Okay, so it says, suppose angle 1 is 55 degrees. 55 degrees for angle 1. Okay, it says we see that angle 1 and angle 2 are, so what are we going to write here? Angle 1 and angle 2 are vertical. Thus, angle 1 and angle 2 are congruent. So you can either write the word or the symbol. So the measure of angle 2 is also going to be 55 degrees. Okay. Easy peasy. That's unit 1 stuff. Easy. Okay. Now we see that angle 2 and angle 3, angle 2 and angle 3 are, well, they're on different intersection groups. 2 is in the upper left and 3 is in the upper left. So I would call them corresponding angles. Corresponding angles, okay? And since the lines G and H are parallel, angle 2 and angle 3, corresponding angles are congruent. Again, you can write the word congruent or you can write the symbol congruent. Doesn't matter to me. So the measure of angle 3 is going to be congruent to measure of angle 1. So that's going to be 55 degrees. Okay. Let's go write 3 in here, 55 degrees. Therefore, because of what we just looked at, therefore, angle 1 and angle 3 are congruent. Okay? They're both 55 degrees. They're saying, hey, look at that. So they are congruent. I'm just going to write the symbol, congruent. We also see that angle 1 and angle 3 are, now in their relationship, they're both on the interior because they're both between the parallel lines, and they're on different sides of the transversal, so they are alternate interior angles. The relationship between angle 1 and angle 3 is an example of the following rule, and you need this rule, so make sure you take advantage of knowing this. When parallel lines are cut by a transversal, what goes there? Alternate interior angles are congruent. Okay? So when you do this topic, you might get one that has alternate exterior angles are congruent as well. They're just trying to lead you to the knowledge of why. Okay, since we know vertical angles are congruent and corresponding angles are congruent, well, if I go vertical and then I go corresponding, then I got 2 angles that are alternate interior and they got to be congruent. Okay, all right, let's finish it here. Introduction to proofs. Okay, I'm going to get just a taste of it in unit 2, and then unit 3 we're going to have a lot of proofs. Right, so they're saying, I'm giving you this statement and your proof. What I want you to prove, the very last statement in your debate, your argument, your reasoning, has to be that line F is parallel to line G. So I'm going to give you a little hint that'll give you partial credit, at least, on every proof you ever do. The first thing you always are going to do is write down the given. Okay, so the given is, it says angle 6 is congruent, which means the same size and the same shape, angle 2. And the reason that I know it's true, why do I know that's true? Because it's given information. Okay, so now that's given information. Angle 6 is congruent to angle 2. I'm going to put little congruent angle marks there. All right, so if they tell me angle 6 is congruent to angle 2, then there is a theorem that says that if corresponding angles are congruent, then the 2 lines that are crossed by the transversal must be parallel. Okay, so that's it. That's all I want to know. We've already said that these 2 angles are congruent. They're corresponding angles. So because of that, I can say line F is parallel to line G, and the reason is, okay, if 2 corresponding angles are congruent, comma, then you have 2 parallel lines. Parallel lines. I'm going to put the lines with a little arrow on each of them. The little arrows indicate that they're parallel. Okay. So they said they want you to prove that F is parallel to G if you know that these 2 angles are congruent. Okay, you just did. You said, okay, angle 6 and angle 2 are congruent. How do I know? Well, they gave it to us. Okay, it was given. Based on that, can I say that F and G are parallel? Yes, because if 2 corresponding angles are congruent, then you have 2 parallel lines. that are crossed by the transversal or cut by the transversal. Okay, now this is also true for alternate interior angles and alternate exterior angles. If they are congruent, then the two lines that are cut by the transversal are parallel. Okay, has to be true. The last thing that would be true here, if they wanted to ask you, if they said, for example, quick example, angle 5 and angles 3 are supplementary. Well, if consecutive interior angles are supplementary, then the lines are parallel as well. So the things that they could have you use for your reason that two lines are parallel. Number one, corresponding angles are congruent. Number two, alternate interior angles are congruent. Number three, alternate exterior angles are congruent. And then number four, consecutive, either interior angles or exterior angles. So we'll just write consecutive interior. It also works with consecutive exterior, are supplementary. Okay, so if any of these are given to you, like this one was, then you can say the two lines that are crossed by the transversal must be parallel. Okay, that's all I have for you. Okay, enjoy it. Hopefully everybody is doing well, finished up with their Unit 1 stuff. If you have any questions on this Unit 2 assignment or any other assignment, please let me know by either email, Google Classroom, Remind. You have lots of ways to get in touch, lots of support. So don't be afraid to ask, okay? See ya.